Hey everyone, we're doing a worksheet on volumes and surface area, and today we'll be discussing some P4 questions. Alright, so let's start the first question of the worksheet, which says volume of each of the following solids is 1000 centimeter cube. Alright, calculate the value of x for each case. In part A, alright, in part A, we have a cube with side length x. So we have a cube whose each side is x, which means its volume will be x cube, and we know the value of volume, which is 1000 centimeter cube. So simply take cube root of this and we'll get 10. Answer for part A, 10 centimeters is the answer. Okay. Part B, a sphere with radius x. So for a sphere, we also know the volume 4 over 3 pi and radius is x cube equals to 1000. Now make x the subject, we'll multiply 3 with 1000, then divide it with 4 pi, and in the end take cube root to make x the subject. So this will become 3000 divided by 4 pi cube root answer, which is 6.2. Okay. Part C. A cone with radius x and slant height under root 5. So a cone with radius x and slant height under root x under root 5. Okay, so we know the volume is 1000, and also the formula for volume is 1 over 3 pi radius square times height. So first we need the height of this cone. So applying Pythagoras theorem, we'll write x under root 5 whole square plus h square plus x square. So this becomes 25x square, in fact 5x square. Under root 5 whole square is 5. So 5x square minus x square equals h square, and 4x square equals h square, and then take under root on both sides, so we get h is equals to 2x. So here we'll use 1 over 3 pi x square times 2x, which gives us 2 over 3 pi x cube equals 1000. Now make x the subject, so we'll multiply 3 with 1000 divided by 2 pi and then cube root. So in my calculator, I'll enter cube root of fraction key on 3000 divided by 2 pi, which is 7.82 rounded off answer, rounded off to 3 significant figures. Okay, please make this correction. This is 27x over 2. I've cropped it a little too much. Alright, so part D, a prism with right angle triangle at its cross section. So volume of the prism is given as 1000, and formula for area of prism is base area times height. So base area is the area of the base or the side that is that's present twice in the figure, the exact same side or the shape which is occurring twice in the figure, and also it's connected by a length which is called the height. So the base is this triangle whose area is half times base times height, and then times height of the whole prism, which is 27x over 2. Height is the length which connects the two identical looking two-dimensional shapes, which are rectangles in this case, which are also the bases of this prism. Alright, so half into base into height times height of the prism, 27x over 2. So this is 1000. So we get 1000 equals 27x cube over 8, then 8000 over 27 cube root. Which gives 6.67 rounded off answer. Correct to 3 significant figures. Question number 2. Part A. Which is the volume of a solid metal sphere is 2. For part 1 we'll probably be using this volume 24430. Calculate the radius of the sphere. So radius is 4 over 3 pi, the volume's formula is 4 over 3 pi r cube. So multiply this with 24430 over 4 pi, then to make r the subject we take cube root on both sides. So 3 times 24430 divided by 4 pi, cube root of answer, which gives 18.0 as the final answer for 8A1. Next up is part 2, which is the metal sphere is placed in an empty tank. The tank is a cylinder with radius 50 centimeter standing on a circular base. On its circular base, okay, water is poured into the tank to a depth of 60 centimeter. Calculate the number of liters of water needed. Okay, so we have the metal sphere is placed inside an empty tank, and we have a tank which is in the shape of a cylinder. The tank is a cylinder with radius 550. Standing on its circular base, water is poured into the tank to a depth of 60 centimeters. So what was the radius of the sphere? Okay, radius of the sphere was 18. So 18 plus 18 will be 36, I suppose. Yes, so this is 36. We need to fill the water level till depth 60. So we have to fill till here 60. So how much water is needed to fill the tank till here? So let's find total volume now. So total volume will be simply volume of sphere, the cylinder. That will be 1 pi r square h. This would be equals to pi times 50 square times 36, gives us 7889.981 and so on. So now let's find volume of water. Will be volume total minus volume sphere. So volume total is 7889.98163 minus volume of sphere, which was minus volume of sphere, which will be 4 over 3 pi r cubed. R was 18. So this gives volume of water, which is minus 4 over 3 times pi times 18 cube. Okay, so I've made a mistake here. This should be pi 50 square times 60, because the length of the cylinder is 60. So pi times 50 square times 60 which gives 4171238. Subtract these: minus 4 over 3 times pi times 18 cube. Okay, when you enter this in your calculator, you get 446,809.87, and then divide it with 1000 to give answer in liters, which is 446.8 liters. Okay, part B. Question number part B. Part B. A different tank is a cuboid measuring 1.8 by 1.5 by 1.2. So we have a tank of these dimensions, alright, and the dimensions are, let's say, 1.8, 1.5 and 1.2 meters. So these are in meters, and notice there's a unit conflict in the question. The water flows from a pipe into the empty tank at the rate of 200 centimeter cube per second. So there's a pipe from which water is flowing here at the rate of 200 centimeter cube per second. And find the time it takes to fill the tank. So this is where we start with. We're given a ratio, which is that when volume is 200 centimeter cube, time is 1, which means in 1 second 200 it's actually 200 centimeter cube of water is entering the tank in 1 second. This is in seconds. Find the time, so time is x now, it takes to fill the tank. So what is the volume of the tank? First we'll find that, enter it in the ratio and cross multiply and get our answer. So volume of the tank is 1.2 by 1.5 by 1.8 meter cubes. So 1.2 times 1.5 times 1.8, which gives us 3.24 meters cube. Change this into centimeter cube, so we'll multiply this with 100, then again 100, then again 100, because 1 meters is 100 centimeters. So for meters, for going from meter cube to centimeter cube, we'll do this thrice, and we get 1 million centimeter cube. Alright, so the volume becomes 3.24 times a million is 324,000 centimeter cube. Let's cross multiply and we'll get our answer in seconds. So x will get multiplied with 200 first, and 1 will get multiplied with 324,000, and then we divide it with 200 to make x the subject. Divided by 200, this gives us 16200 seconds. Alright, so now change this into hours and minutes. So divided with 60, we get 1. In fact, let's divide it with 60 and again divide it with 60 to get hours. So I divide it with 3600 and I get 4.5 hours, and they want the answer in hours and minutes. So 4 hours and 0.5 hours are 30 seconds. Answer for question 2 part B. Question number 3. The diagram diagram shows the hemispherical ball of radius 5.6 and a cylindrical tin of height 10. Show that the volume of the bowl is 368 centimeter cube, correct to the nearest centimeter cube. Okay, so A1 is show that the volume of the bowl, so the formula for volume salt inside the cone is 18.9. So volume of the cone will be now volume of salt, in fact, will be volume of large cone minus volume of the smaller cone, right? So we have the volume of the whole cone from part, no, we don't, we need to find that out as well. Also we don't have the radius for the smaller cone. So first we'll find the radius of the smaller cone using similar figures, which says r over 1.75 equals 1.5 over 6. So r will be equals to 1.5 times 1.75 divided by 6, which gives us 0.4375. So volume of the larger cone will be 1 by 3 pi radius square times h minus volume of the smaller cone is 1 over 3 pi radius square times h. So enter all of this in your calculator. I'm getting 18.941, which when rounded off will give me 18.9, correct to 3 significant figures. Part B. We're doing B part 2, part B, the last part. This one, part B. This one. Okay. The salt is removed from the cone at a constant rate of 200 millimeter cube per second. Calculate the time taken for the cone to be completely empty. So again, this is a ratio between volume and time. For when time is 1 second, 200 in 1 second 200 millimeter cube of salt is removed. Calculate the time taken for the cone to be completely emptied. Alright, so the cone had salt in it, and what was the volume for salt we got in the last part? That was 18.94. I will be using the unrounded off ones, 18.94159, and this value is still flashing in my calculator. So I'll cross multiply, so I get x equals 18.9415. Oh no, but do we have a unit conflict? Yes, we do. This volume was in centimeter cube. So first we need to change it into millimeter cube. So we have 118.94159 centimeter cube. Change it into millimeter cube by multiplying it with 10, again with 10, again with 10. So multiply it with 1000, we get 18941.59 millimeter cube. So 18941.59477, etc. millimeter cube. Now cross multiply. So x will be equals to 1 times answer times 1 divided by 200, which gives me 94.7079 seconds, and rounded off to the nearest second, so 95 seconds. Nearest second. Question number 4. Calculate. Question number 4. Part A1. Calculate the external curved surface area of a cylinder with radius 8 and height 19. Okay. External curved surface area means just the surface area of the circular region of a cylinder, this one. So the formula for that is 2 pi r h, and the radius is 8 and the height is 19. So we get 2 times pi times 8 times 19, we get 995.0441. This is part A 1. Okay, so rounded off answer is this was 955. So 955 is the rounded off answer. Part 2, this surface is painted at a cost of $0.85 per meter square. Calculate the amount of painting, calculate the cost of painting the surface. So we have a ratio that to paint 1 meter square, it will cost us $0.85. So to paint 955.0 etc. meter square would cost us how many dollars? So simply cross multiply, and x will be equals to answer times 0.85, which gives us 811.78, and rounded off to 3 significant figures, this is $812. Part B, a solid metal sphere with radius 6 is melted down, and all of the metal is used to make a solid cone of radius 8 and height h. Show that h equals to this. So volume of the cone equals volume of sphere. So the formula for volume of cone is 1 by 3 pi radius square. So radius of the cone is 8 square, and we don't know the height, so h equals to volume of the sphere is 4 over 3 pi radius cube. So radius of the sphere was 6 cube. So now cross multiply, cancel, etc. over divide by 3 gets cancelled, pi and pi get cancelled. So h equals 4 times 6 cube over 8 square. This gives us 4 times 6 cube divided by 8 square. This gives us 13.5, which we were supposed to show here. Okay, part B2 is calculate the slant height of the cone. So we know the height of the cone is 13.5 and the radius of the cone is 8. To find the slant height, we'll be applying Pythagoras Theorem, which is L square equals 8 square plus 13.5 square. Next, take under root of these values, 8 square plus 13.5 square. Which gives 15.692, which is 15.7. Okay, for the next part we have to find the curved surface area of the cone. So B3, find the curved surface area of the cone, and formula for curved surface area of the cone is given here as well, which is pi RL. So radius is 8 and L came out to be 15.692 ... and we have this value in our calculators, showing in our calculators. So answer times 8 times pi gives me Yes, the answer is 394.391, which equals to 394, rounded off to three significant figures. I think I forgot to copy the rest of the answers here, so note them down. Okay, next up is part D, which is the diagram shows a pyramid with a square base ABCD. DB is 8 centimeters. So this length is 8. This is DB equals 8. P is vertically above X of the base, and PX equals 5. And this is equals to 5, length of PX. Calculate the angle between PB and the base ABCD. So we need this angle between PB and the base. So we're looking for angle P to B to X, right? So we have this height 5, and we have the length XB as well, which will be half of 8, which is 4, and we need the angle simply. So to find the angle, I can see a right angle triangle, and I apply tan theta equals to perpendicular over base. So theta equals to tan inverse of 5 over 4, inverse tan 5 by 4, which gives me 51.3, rounded off answer. Question 5. The diagram shows a prism ABCDEF. The cross section is a right angle triangle ABCD, which will serve as the base of this shape. Okay, and we have certain dimensions 10, 5.2 and 18. Work out the volume of the prism. So for 1A, volume of the prism is base area times height, and base area is a half into 5.2 into length DC. We don't have the length DC, times height of the prism is 18. So we need the length DC first. For that we will apply Pythagoras theorem. So 10 square equals 5.2 square plus DC square, and to make DC the subject, I'll rearrange this: minus 5.2 square whole under root, and this will give me under root 10 square minus 5.2 square, which gives me 8.54166, etc. And alright, so I'll substitute this value here and get 0.5 times 5.2 times answer times 18, which gives me 399.7498. So this is 400, correct to three significant figures. Part B. Calculate angle BEC. So this is B, this is E. So we're looking for this angle. This is B, E, and then this is EC. So we need this angle. Let me redraw it. For part B, we have B to C, which is 5.2. We don't have length C to E, and we don't have length E to B either. So we need to find EC first, again by using Pythagoras theorem. We've already got DC, which is 8.5416. I'll write till 4 decimal places at least. because whenever we're using a particular value in the next part, we're supposed to use the unrounded off answer. Alright, so we need EC, and I'll be using this triangle now, this right angle triangle. This is E, this is C, this is D, this is 18, and this one is 8.5, etc. So I'm again using Pythagoras theorem directly. Under root 18 square plus 8.54166 square. So EC will be 18 square plus 8.54166 square under root answer. I get 19.9238. So this becomes 19.9238. Now I can find theta by applying tan. Tan theta is equals to 5.2 perpendicular over hypotenuse, 9.9238. So to find theta, I'll take tan inverse of the fraction. Tan inverse bracket 5.2 divided by answer. I am getting 14.6, which is the correct answer. The angle is 14.6 degrees. Angles are supposed to be rounded off to 1 decimal place. Okay, so for part 2, B2, a point G lies on ED such that GD is 7. So G is somewhere over here. GD is 7. That makes E to G 11. So this is 11 and that's 7. Okay, work out angle BGE. So we need the angle B to G to E. We need this angle. Okay, so this angle to be precise. So the angle in purple is not part of a right angle triangle, so I can't use trigonometric ratios there. But what about this angle? Notice that this shape ABED is actually simply a rectangle ABDE, right? So that means this angle is a right angle triangle. So this angle here is a right angle triangle. It's just a tilted rectangle, so the corners are still of 90 degree. So I can apply Pythagoras theorem in this triangle GBD, where this is 10 and this is 7. So I'll apply tan theta here is equals to perpendicular over base. Theta is equals to tan inverse of this fraction, and I believe it gives 55. So the angle in yellow is 55. So to find the required angle, we'll do 180 minus 55, which gives us 125. Answer for the last part. Okay, question number 6. Part A, the diagram shows a solid prism with length 15.2. The cross section of a prism is a regular hexagon with side 7. Calculate the volume of the prism. So to find the volume of a prism, we will be using the formula base area times height. Next we need the base area, which is area of this hexagon. Now since it's a regular hexagon, we'll use the formula 180 times n minus 2 over n to get one interior angle of the hexagon. So I get 180 times 4 divided by 6, which is 120. So now each angle is 120 degrees. Each interior angle is 120 degree. And each side is 7. So we will need to apply trigonometry to break it into subparts and get the values. Okay, so let's break it into subparts. I'll make a line here a line here, and a line here. So I have four identical rectangles, two identical rectangles and four identical squares. Now I need the areas of one square and one rectangle to find area of the whole thing. This would be 60, right? This is 90, this is 90 as well, and this would be 30. So using this triangle, 90, 60, 30, and this length is 7, I can find the other two lengths. I can find this length, which will be equals to this length and this length, and I can find this length, which would be this length and this length and this length and this length, all of these. Alright, so I'll be applying trigonometry here quickly. So if I'm using 30, so I'll use some sine theta. Sine 30 equals to the purple side, let's call it x over 7. Sine theta is equals to perpendicular over hypotenuse, so x is 7 times sine 30, which is 3.5. And then so the purple length is 3.5, this is 3.5, and this is 3.5 as well. Let's find out the blue length now. Blue length will be found using, let's say if I'm using 30 again, then this will be the base, and so I'll be using cos 30 equals base, let's call it y, over hypotenuse, so y equals to 7 times cos 30, which is a huge value, 6.062177. Alright, so this length is 6.062177. So I have the dimensions for the triangle, but I'm still missing one dimension for the rectangle. I still need this, and this would simply be 7, because this side is 7 and also this is 7, so this is 7. Now I'll simply add the areas of 2 rectangles and 4 triangles to get the base area. So let me write that here. Base area will be equals to 2 times area of the rectangle, which is 7 times 6.062177. This value is still being shown in our calculator, so we'll use it as it is, plus 4 times half into base into height, which is again 6.062177. So the base area comes out to be 127.3097. Now substitute this value here. So volume equals base area times height of the prism is 15.2. So multiply this and we'll get 1935.04. so rounded off you can write 1940. So 1940 in our case. Okay, question number 7, part A. The diagram shows a prism of length 12. The cross section is a regular hexagon with side 4. Calculate the total surface area of the prism. Now the total surface area would be this, it's a regular hexagon, so each side is 4. So we have 6 rectangles of dimensions 4 times 12, plus 2 times of area of one hexagon, which is called the base area. So we have to find the base area now. So just like in the previous question, I will just quickly revise it. We found out that one interior angle is 120, and I will split it into subparts. In fact, I won't be doing it again, so you can refer to the previous question in case you missed that or fast forwarded that. This is 60, this is 90, this is 30. No, in fact these dimensions are different from the previous questions, so no, we'll be doing these from scratch. So this becomes 30. Now we need, this is 4, 4, this is, all the lengths are 4, this is 4 as well, this is 4 as well. So I need this length, which is also equals to this length, and this length, which is also equals to this length, and this length. So I'll be using trigonometry. So I am making this triangle here, this one, then this, and then this. Okay, so this is 90, this is 60, this is 30, and this is 4. Now I'll be using trigonometry to find the purple length and the blue length. So if I use sine theta equals to perpendicular over hypotenuse, this will give me x, and if I use cos theta, if I'm using 30, then the base is y and hypotenuse is 4. So x is 4 times sine 30, which is 2, and y is 4 times cos 30, which is a long decimal number, 3.4641, so on. So the purple length is 2, so this is 2, this is also 2, and this length is 3.4641. Now to find the base area, I will be using 4 times area of one triangle, half into base into the blue length 3.4641, plus 2 times area of the rectangle, which is 4 times 3.4641. So remember, this answer is still flashing in the calculator, so you may just use the answer key here. So the base area comes out to be this. Substitute the value in this formula and we will get 371.138, which rounded off to 3 significant figures becomes 371. Next part is part B. Part 1. Water flows through a cylindrical pipe of radius 0.74 centimeters. It fills a 12-liter buckets in 4 minutes. So there's a 12-liter buckets that's completely filled in 4 minutes. So calculate the speed of water through the pipe in centimeters per minute. Okay, so we'll be using ratios here. We know that 12 liters, which is equals to 12,000 centimeter cube. So 12,000 centimeter cube is being filled in 4 minutes. And they want the answer in centimeter per minute. Alright, so in 1 minute, how much volume will be filled? So in 1 minute, 12,000 divided by 4 centimeter cube will be filled. So now this is the volume passing through the pipe in 1 minute. So in 1 minute, this much volume, let's say this much volume is passing through the pipe. Okay, so now, and this will be the height. So I know volume of a cylinder is pi r square h, and the volume in 1 minute is 3000 equals pi 0.74 square times height, which I need to find. I'll make height the subject, and I'll get 300 divided by 0.74 divided by bracket 0.74 square times pi, which gives me 1743.84 centimeters. So this is how many centimeters is passing through the pipe in 1 minute. So this is the speed. So rounded off to 3 significant figure, this becomes 1740 centimeters per second. Or you could also use speed equals distance over time, where distance is the height, the distance being covered in 1 second, that is 1743.84, and the time was 1 second, 1 minute from here, sorry. And I think we were supposed to give answer in minutes. In centimeters, yes, this is minutes, not seconds. Okay, the next part is when 12-liter bucket is emptied into a circular pool. So we have a circular pool, which means it's a shape of a cylinder. Alright, so when a 12-liter, so we enter 12-liter in it, and it's emptied into a circular pool, the level rises by 5 milliliters. So there's a 5 milliliter increase in the level of water. So 5 ml, let's say, millimeter increase in the level of water. Calculate the radius of the pool correct to the nearest centimeters. So let's see, if I only take this chunk of the pool, its volume is 12 liters. 12 liters is 12,000 centimeter cube, equals to formula for volume of a cylinder is pi r square, height is 5 millimeters, and this is in centimeter cube. So let's change this into centimeter, is equals to how many centimeters. So for that we divide it with 10, simply divide it with 10, and we get 0.5 centimeters. So this is 0.5. Now let's simply make r the subject. So 12,000 divided by 0.5 pi under root equals r. I'm getting 87.403. So 80 correct to the nearest centimeter is 87. Question 8. Part A, calculate the radius of the hemisphere. We know the volume, which is 230, and the formula for hemisphere, volume of hemisphere is 2 by 3 pi r cube. Make r the subject. So 230 times 3 divided by 2 pi and cube root of answer. So 230 times 3 divided by 2 pi and cube root of answer, which is 4.79 rounded off to 3 significant figures. Part B, a solid cylinder of radius 1.6 is attached to the hemisphere to make a toy. The total volume is 3000 centimeter cube. Calculate the height of the cylinder. So now the total volume is 3000, and we already know the volume of the hemisphere, which is 230, plus volume of the cylinder, which is pi r square h, and we know the radius, which is 1.6 square, and we don't know the height. So we'll simply rearrange 300 minus 230 is 70, and we'll divide it with 1.6 square times pi, and we get 8.7. Okay, next question, question 9. Which is part A. Water flows through a cylindrical pipe at the speed of 8 centimeters per second. The radius of the circular cross section is 1.5. This is 1.5 centimeters. And the pipe is always completely full of water. Calculate the amount of water that flows through the pipe in 1 hour. Give your answer in liters. Alright, so we're told that in 1 second 8 centimeter water passes. So if this length is 8 centimeter, then how much volume is being passed through the pipe in 1 second? So we'll be finding that out first. The volume of water passing through the pipe in 1 second. So that would be volume in 1 second will be pi r square h, and this would be pi times 1.5 square times h, which is 56.54866 centimeter cube. Now in 1 second 56.54866 centimeter cube is passing, and they want the volume in 1 hour. 1 hour is 3600 seconds. How much volume will be passing? So x will be equals to 3600 times answer, which gives us 203,575.2 centimeter cube divided with 1000, and we get 203.575, and when we round it off we get 204 liters. This is part A. Okay, part B. The diagram shows 3 solids. The base radius of the cone is 6, the slant height is 12, the radius of the sphere is x, the radius of the hemisphere is y. The total surface area of each solid is the same. Part 1 show that the total surface area of the cone is 108 centimeters square. Okay, so we have all the dimensions for the cone, and we know that the total surface area of the cone is pi rl plus pi r square. So pi times radius times the slant height plus pi times radius square. This gives us 6 times 12 times pi plus 36 pi, and we get 3. Alright, so there is a typing error in the question. This is 108 pi. So we have to give the answer in terms of pi. So simply take pi common here and solve the rest. Plus 36 plus 12 times 6, 72. So we get 108 pi. Okay, next up is part 2. Find the value of x and the value of y. So we know the total surface area for all of the figures is the same. So for part 2, surface area of a sphere is 4 pi r square, which is equals to 108 pi. Cancel out the pi's to make x the subject., take 108 over 4 whole under root. So under root of 108 over 4 is 5.196 rounded off to 5.220. 5.1961, so that this is 5.20. Correct to three significant figures. Then we have to find y. So the volume of the hemisphere, complete volume of a hemisphere, will be 108 pi, which is equals to volume of this circle first, which is pi y square, pi r square, plus volume of half of this sphere, just lower region only, so plus 2 pi r square. So let's take pi common from the left hand side and cancel with the right hand side. So pi and pi get cancelled, then we get 108 over 3 under root equals to y. Because this becomes 3y square, then you divide 3 and then you take under root. Okay, so under root of 108 divided by 3, which gives us exactly 6. Okay, question number 10. Let's make this the last question of the worksheet. Okay. Question 10. Oh man, sorry about that. Okay. Yes. So the diagram shows a prism with length 18 and volume 253.8. Show that height is equals to this. So the volume equals to base area times height. Height is 18 in this figure, and base area will be half times base times h times 18 equals to 253.8. Make h the subject. 253.8 times 2 over 6 times 18. This should give us 4.7. Let's see. 253.8 times 2 divided by 6 times 18, which gives us, yes, 4.7. Okay, so this was one. Find the value of x. To find x, we'll apply trigonometric ratios. This came out to be 4.7. This is 6. We need this angle, so we'll do theta equals tan inverse perpendicular over base through proper brushing. So theta should be tan inverse 4.7 over 6, which gives us 38.072, so rounded off to 38.1 degrees. And then part B, calculate the total surface area of the prism. So for that, we have the area for the rectangle. This will be half times base times height, and we'll multiply this with 2. Then we have area of this rectangle, base times height. And do we have, yes, we have the area of the lower rectangle as well, the one at the base, this one. We have the area for this because we have all the dimensions. What we don't have is one of the lengths of this rectangle. So we know this dimension is 18, but we don't know this. So first let's find out this length in red, and then we'll simply add all the areas. Alright, so for part B, we know this is 4.7 and this is 6. So apply Pythagoras theorem to get this length in red. This length simply. So that would be 4.7 square plus 6 square under root. Which is 7.6216. So this becomes 7.6216. Let me quickly recheck it. 4.7 square plus 6 square under root answer Yes, this is what we get. Now I need all the areas, so I'll simply start adding all the areas. So I'll write 2 times half times base times height. Height came out to be 4.7. I just found out areas of the two triangles. Then I'm finding area of the lower rectangle, which is 6 times 18. Then I'm finding the area of the rightmost rectangle, which is h times 18. H was 4.7, plus area of the slant rectangle, which is 7.6216 times 18. So let's see what this gives us. Okay, we get 357.990, which rounded off gives 358. Alright, so let's just end this worksheet here. I'll see you next time. Take care.